Every experiment has two variables, an explanatory variable, which we call the independent variable, and a response variable, which we call the dependent variable. The explanatory variable describes the level of the treatment that we're giving. The response variable measures the outcome or the response to our explanatory variable. So suppose we want to test a new cancer drug on people who have cancer, and this drug is supposed to increase the white cell count in their body and help them to combat the cancer in a better manner. In this instance, the various dosages of the drug are the explanatory variable. And then the white blood cell count represents the response variable, the outcome. It is what may change as a result of the explanatory variable that we've given. Both explanatory and response variables can take on different values. If those values are non-numerical, they are called qualitative variables or sometimes categorical variables. Examples of qualitative variables are gender and ethnic origin. Variables that have numerical value are called quantitative variables. Some examples: 230 people, 2.85 inches, 12.5 ounces, 120/80 blood pressure. We have two types of quantitative variables. We have discrete variables, which consist of 0 and all counting numbers, 1, 2, 3, 4, 5, all the way up to wherever we want to count to, and continuous. And we use continuous whenever we measure things that could have decimal values or fractions in between. The number of books on a shelf, the number of people in a line, the number of people who say yes to a question are all discrete values since they refer to a count. We measure height, weight, volume, and other physical measurements as a continuous variable since we can measure to various decimal places or fractions.